Something extremely big is about to happen to our galaxy. The Milky Way and our next-door neighbor Andromeda are heading directly for each other, like two galaxy-sized freight trains on the same track. That's right, we're about to plow head-on into an entire galaxy. It's going to be an epic universal mashup, and it's right around the corner, from the perspective of galactic time spans. Today, we've brought the Andromeda-Milky Way collision forward in time 4 billion years so that you can have a front row VIP seat as these galaxies smash into each other at over 400,000 kilometers per hour. Hey, an asteroid smaller than the island of Manhattan wiped out the dinosaurs. What's going to happen when we get smashed by an entire galaxy? You're going to want to stay up for this because we're taking you on a trip to witness firsthand what happens when galaxies collide. Standing looking at the night sky, you might not feel like you're moving, but hold on tight. You're already traveling near the speed of sound because you're spinning with the Earth's rotation. If you're in the mid-latitudes in places like North America and Europe, you're already traveling at about 1,180 kilometers per hour. That's 733 miles per hour. Now, you don't feel it because it's a constant. You've been traveling at this speed since the day you were born, and so is everything around you. But if Earth suddenly stopped spinning, well, then you'd find yourself and everything around you flung out into low orbit at about 1,000 kilometers an hour. Add to that, you're also traveling around the sun. Earth is orbiting our favorite star at about 30 kilometers per second. That's 18 miles per second, which is almost 100,000 kilometers per hour. And in turn, the sun and the rest of our solar system are orbiting the center of the Milky Way galaxy at an astonishing 720,000 kilometers per hour. So, without even knowing it, you're traveling 750,000 kilometers every hour. And you don't even feel it. And we're blasting through space on a collision course with another galaxy. Andromeda is our galaxy's closest neighbor, and it's getting closer. Or we're getting closer to it. It's both, actually. The two galaxies are close enough that their gravitational attraction to each other overcomes the general expansion of the universe. So it's more like the Milky Way and Andromeda are falling into each other. If you could step back, it's like two bright rotating disks in space merging into each other in one big cosmic clash of the titans. And they won't just collide once. The two galaxies will actually rip right through one another, then stop and fall back into each other. Again and again and again. Collision after collision until they settle down into one new singular galaxy. And what a mashup they're going to make. Andromeda is a massive galaxy containing about 1 trillion stars. And the Milky Way is not exactly a lightweight. We have about 300 billion stars. At a distance, it looks like it's going to be a cosmic smash-up derby. Close up, the distance between the individual stars is actually enormous. Yeah, the average distance between stars is about 5 light years, or 47 trillion kilometers. For instance, the nearest star to us in our celestial neighborhood is Proxima Centauri, which is 4.24 light years away, or 40 trillion kilometers. So there's a lot of room for the star systems that make up these galaxies to just quietly slide past one another. To visualize it, if you scaled Earth down to the size of a couple nanometers, about the size of a virus, our solar system would be about the size of a golf ball. And at that scale, the Milky Way galaxy would be about the size of North America. So yeah, imagine the likelihood of two golf balls flying at each other from opposite sides of the United States colliding. It's a 1 in several billion chance. But in this case, it isn't two golf balls, it's trillions. So even though it's incredibly unlikely, it is possible another star system could pass close enough to disrupt our solar system. And if two star systems were on a perfect collision course, it would be devastating. Even more devastating if one of those hypothetical star systems was aimed right at our solar system. Then it'd be personal, and you're there to see it all. So, what would it look like? If one of Andromeda's trillions of star systems crashing into our galaxy passed close enough to our system, the first signs would be subtle but unmistakable changes in the sky. Scientists watching with telescopes would be the first to notice it. To you on the ground, well, you wouldn't see it until a little later. You'd notice a new and unusually bright star in the night sky. It would take centuries, but it would slowly get brighter and brighter. And it wouldn't be like other stars. Instead of staying fixed in place like a normal star, it would stand out as it moved around relative to the background. As it got closer and brighter, its motion in the night sky would become more and more obvious and more concerning. The approaching star system would eventually be the most obvious light in the night sky, outshining literally everything else. And then the fireworks would really start. The action would begin way out in the Oort cloud, which is an almost impossibly huge bubble of icy debris that surrounds our solar system. It sits between 300 billion kilometers and 750 billion kilometers away. To give you an idea of how extremely far that is, well, NASA's Voyager 1 spacecraft won't enter the Oort cloud for another 300 years, and it's traveling 1 million miles a day. Even more mind-blowing, once Voyager 1 gets to the Oort cloud, it'll take around 30,000 more years to get through to the other side. So it's way out there, and it's huge. The approaching star's gravity would act like a bull in a china shop in the Oort cloud, scrambling the ice chunks and planetesimals that make up the cloud. And as this cosmic debris was stirred up, it would fan out in a surge of new comets hurtling toward our solar system. Down on Earth, you'd have a front row seat to a light show for the ages. The skies would light up with thousands of comets and transient objects flaring out as they burned up in the atmosphere. And as the hurtling star system got closer, invisible but much more ominous changes would be happening. After blasting through the Oort cloud, the chaos would arrive in the donut-shaped zone called the Kuiper Belt, out past Neptune on the edge of our solar system, and a lot closer to home. Astronomers would start to detect gravitational anomalies and small but measurable changes in the orbits of the icy fragments, the dwarf planets, and the comets that make up the belt. Then, the star system barreling toward us would be felt by the outer planets. Neptune, Pluto, and Uranus would subtly start to change course as the rapidly approaching star's gravitational force began to pull and tear at our solar system's delicate balance. Because even a close pass could be devastating. Right now, our solar system is relatively stable, with every planet having settled into its relationship to the Sun and other planets over hundreds of millions of years. It's like a huge but finely adjusted web, held together carefully with a system of invisible, counterbalancing gravitational forces. And there's nothing significant coming into our system from outside to disturb it. We're surrounded by billions of kilometers of empty space. It's a great setup, and we'd like to keep it that way. But if any of these passing solar systems got close enough, the gravitational pull would stretch and distort planetary orbits, setting the stage to throw our solar system into chaos. First, with the two giant anchors that keep our solar system in balance. Saturn and Jupiter would deviate from their previously stable orbits. As Earth's own motion around the Sun is affected by the cascading energy of the big planets' shifting position, even the first small changes in Earth's orbit would cause the Moon's orbit to become elliptical. In extreme cases, the Moon would even peel away from Earth, or, in the worst-case scenario, plunge inward toward us. On Earth, these first noticeable effects would be environmental rather than immediate destruction. Changes in Earth's orbit would alter the amount of solar energy we receive, disrupting climate patterns and seasons. Crops would fail, forests would die. Life on Earth has evolved to live within a very narrow environmental band, and humans thrive in an even narrower part of it. Tiny changes in Earth's distance from the Sun could render it uninhabitable for us in a matter of years. As the oncoming star system gets even closer, well, whole new planets would be cruising through our home system. Your front row seat is starting to get a little uncomfortable. As instability on Earth increases, gravitational interactions become extreme, triggering enormous tidal forces and unleashing earthquakes worldwide. Even greater changes in Earth's orbit would lead to catastrophic temperature shifts, oppressive heat waves lasting for months, and winter freezes that we've never experienced before. It's been thousands of years since you first saw that bright star in the sky, but now it's approaching fast. And what if our planetary orbits intersect? If an Earth-sized planet narrowly misses us, well, we wouldn't exactly be home free. Its gravitational force would grab at Earth's mass and pull us roughly out of our comfortable orbit. The stress on Earth would be incredible. The gravitational forces would be so powerful that they'd actually distort the shape of our planet. Seeing this from the surface of Earth, the nearing planet would loom large, a multicolored marble in the sky, filling it. The oceans and seas would slosh around like water in an unsteady bowl, surging into massive tides. You'd be staring down extreme tidal waves kilometers high. And the ground beneath your feet would shake violently and heave. The sound would be deafening. Earthquakes would level everything. Earth's crust would break and rupture. Cracks would open and swallow cities whole, and then close back up in giant collisions. Fountains of hot magma would shoot up into the sky and fall back to Earth, setting everything on fire. And that's just the pregame show. A truly close approach would act on Earth like a kind of giant slingshot. As the planet passed, it would accelerate Earth out of our orbit and into a hyperbolic trajectory. If the force were strong enough, Earth would be flung so hard that we wouldn't just change orbit and find a new balance rotating around the Sun. Our orbit would be so eccentric that we'd be ejected from the solar system entirely. If Earth managed to avoid smashing into one of the other destabilized planets on our way out of the solar system, well, we'd speed further and further into space. As you looked back, the Sun would be getting smaller and smaller in the rearview mirror, and sunlight on the surface of Earth would drop dramatically. After as little as 14 days, you might even get a chance to wave bye-bye as you fly past Mars. By now, the Sun appears to be 2/3 its normal size. Things would cool down quickly on Earth. The average temperature would drop to minus 50 degrees Celsius. As you leave the outer planets behind, it's going to get downright chilly. Temperatures on Neptune hover around minus 200 degrees Celsius. That's minus 330 degrees Fahrenheit. So that gives you an idea of what you'd be experiencing. By now, the sun is just a bright star in the sky. The oceans would freeze over. Even the atmosphere would compress and condense as the temperatures continue to plummet. As you exit the solar system, Earth would become what's known as a rogue planet, which, yeah, sounds cool, but life on this rebel rock would pretty much suck. As we got further out, well, there would be little or no solar input. Eventually, rogue Earth's only heat would come from residual geothermal energy deep within our core. Now, if humanity had enough advance warning, well, some of us could survive, but we'd have to get our heat and light and food from artificial sources like nuclear reactors. And we'd have to live in an insulated fortress protected from the extreme cold. The sky would be permanently dark, no sunrise, no sunset, and survivors, if there were any, would be cold, lonely voyagers trapped on a rock, spinning through the blackness of space for millions, maybe billions of years. Maybe even till the end of the universe and time itself. Now, obviously, a close flyby that slingshots Earth into a completely uninhabited orbit or out into the cold expanse of outer space wouldn't be great, but if that's not bad enough, how about the absolute worst case scenario? What if one of those passing planets smashed head-on into Earth? As you watched the approaching planet from the surface of Earth, it would absolutely fill the sky, but this time, it wouldn't stop growing. There would be tides 1 kilometer high that level coastal cities, earthquakes on a planetary scale that tear open continents, and volcanic explosions everywhere as Earth's crust is pulled, stressed, and distorted. Then, the sky would be filled from horizon to horizon with the oncoming planet, and it would happen fast. The two planets' gravitational fields would be wrestling with one another, creating tidal stripping as they tore off parts of each other's atmospheres. A glowing stream of matter would form between them. By this time, you'd be vaporized, but if you could stick it out a little while longer, witnessing the collision itself would be spectacular. As the two massive planets made surface-to-surface contact, the impact would release the energy of billions of nuclear bombs. And remember, these planets are moving extremely fast relative to one another. This isn't a fender bender between two compact cars, this is a head-on between two fully loaded semi-trucks. You're going to be standing on 6,000 billion trillion metric tons of planet, smashing into 6,000 billion trillion metric tons of planet at a speed of 400,000 kilometers per hour. That's gonna hurt. The heat generated would completely melt and vaporize both planets, leaving a massive glowing cloud of swirling, churning, superheated rock and gas. As this hellscape settled, gravity would do its work, and this cloud of hot material would pull together to form a completely new planet. This is how we think the moon formed billions of years ago, when Earth was hit by a Mars-sized object named Theia. That impact was so powerful that it launched massive globs of molten material out into space, some of which fell back to Earth, and some of which came together to form the moon. But in this case, a direct collision with a similar-sized planet, Earth would be no more. Now, since you're lucky enough to still be around, well, you'll get the first chance to name this new planet. It likely won't be habitable for a few billion years, if ever, so don't expect a real estate boom there anytime soon. Of course, it might not be a planet that passes by or hits Earth. It could be the star at the center of the passing system that scorches us as it drags us away in its gravitational field. Or something even more frightening, because the fact is, at the heart of the Andromeda Galaxy sits a monster black hole, which has a mass of more than 140 million suns. In the off chance that our solar system was unlucky enough to get in the way of that, it would vacuum us up like a gigantic cosmic Roomba, and we'd be gone without a trace. Even if the chances of this are extremely unlikely, but you'll never know what's going to shake out as two massive galaxies collide. The scale of this rearrangement is going to be like nothing we've ever witnessed before, and odds are there will be some damage. So, could Earth and our solar system survive this cosmic demolition? Well, the answer is yeah, more than likely. Now, the odds of making it through this galactic merger of giants without coming close to another celestial body are relatively high. Just remember those golf balls flying across the United States. Just like you don't feel the fact that you're currently traveling through space at 720,000 kilometers per hour, our solar system would be gently and quietly pulled into an entirely new orbit around the merged galaxies. It'll take billions of years, and the changes will happen so slowly that our solar system would remain almost completely oblivious to the new arrangement. From a distance, the two galaxies would lose their distinct disk shapes as they combine, moving through all kinds of wild star formations and into a single tangled structure some astronomers call Milkdromeda. Now, as you witness this kinder, gentler collision, the combined galaxy would become a crowded, luminous star field with many, many more visible stars. All the familiar constellations would be rearranged and overwritten. The sky would be a panorama of new shapes and clusters and glowing sheets of color and shine down much brighter than today's starry nights. Thankfully, you didn't have to wait 4 billion years. You get to see it live in the best time ever, seeing galaxies collide and star colors explode and fly off into space from the comfort of your couch. But don't get too comfy now. Remember, you're spiraling through space at 720,000 kilometers per hour, destined to collide with another galaxy. But that might be the least scary cosmic encounter. Imagine two black holes aimed at one another. Well, that's a story for another What If.